Hey there. We all write code, but have you ever just paused for a second and wondered what happens in that first moment after you hit run? How does a machine even start to understand our language? Well, today we're going to pull back the curtain on that very first, super important step.
Take a look at this line of code. It's pretty simple, right? Something you've probably written 100 times. Our brains, they just instantly get it. We're assigning a value to an element in an array. But to a computer, it's not a statement with meaning. Not yet. To the compiler, this is just a jumble, a sequence of raw characters, A, then a bracket, I, N, D, and so on. It's kind of like being handed a big pile of Scrabble tiles and being told to make sense of it. So where on earth does it start? How does it turn that chaos into order?
Well, that very first step is done by something called the lexical analyzer. Sometimes people just call it the scanner. Think of it as the very first reader of your code, and its whole job is to perform the most basic but most critical level of organization. I like to think of the lexical analyzer as this really meticulous librarian. It doesn't care about the story in the book. Not yet. Its only job is to sift through that pile of individual letters and neatly group them into complete words. And in a programming language, these words are what we call tokens. And you can really see that transformation right here. That one long stream of characters from our code gets organized into these distinct, meaningful little units. Suddenly, it's not a jumble of text anymore. It's now understood as 8 separate words, or as we call them, tokens. So our code is now a series of tokens. But what is a token, really? Let's zoom in a little bit, because it's actually more than just splitting the code by spaces. It's all about classification. See, each token has 2 parts. You've got the lexeme, that's the actual string of characters from the code, like A or index. But then you have the token type, which is the category it belongs to. So the computer now knows that A isn't just a letter, it's an identifier, a name for something. And 4 isn't just a character, it's a number. This is the very first layer of meaning being created. So really, it all boils down to this incredibly simple, repetitive process. The scanner reads characters one by one, groups them into the smallest valid units it can find, and then passes this organized stream of tokens along to the next part of the compiler, the parser. The parser is the one that's going to figure out all the grammar and structure. Okay, but that brings up a really good question, right? How does the scanner know what to group together? How does it know that INDX is one thing, but that a single plus is a totally separate thing? Well, it does this by using a really powerful rulebook. And that rulebook is written in a language called regular expressions. Now, you don't have to be a wizard with the syntax here, it's the concept that matters. A regular expression is just a formal way to describe a pattern. And the lexical analyzer, it has a specific pattern for every single type of token it needs to be able to recognize. And what's so cool is how simple these rules can be. The pattern for an identifier? Easy. It's a letter, followed by maybe more letters or numbers. A number, just a sequence of digits. And the pattern for a plus sign is, well, just the plus character itself. It's these really simple rules that define all the basic building blocks of a language. But, sometimes things aren't so clear-cut. These patterns can create a bit of a puzzle. For instance, what happens when the scanner sees the character I and then an F? It has a choice to make. I on its own is a valid identifier, but if could be a special keyword. What's it supposed to do? Let's put it another way. How does it decide where one token ends and the next one should begin? I mean, if it just stopped at I, the whole meaning of the program would be completely different. There has to be some kind of tiebreaker rule. And the solution is just beautifully simple. It's often called the longest match rule. Basically, the scanner is greedy. It will always try to gobble up as many characters as it possibly can to form the longest valid token it can find. This slide just nails how that rule works. As the scanner is reading the word while, it doesn't just stop at W, even though that's a perfectly valid identifier. Nope, it keeps going. WH is valid, WHI is valid. It only stops when it gets to the end of while and sees, say, a space. Then it looks back and takes the longest complete token it found, the keyword while. Simple as that. So we've seen how this first little reader of our code works. It groups characters into tokens using patterns and this longest match rule. But what's the big takeaway from all this? Why does any of this really matter? It's all about a core idea in engineering: divide and conquer. By having the lexical analyzer handle the simple but kind of messy job of dealing with raw characters in whitespace, it frees up the next stage, the parser, to focus on the much harder job of understanding the program's grammar. It breaks one huge, complicated problem into two smaller, much more manageable ones. And here's where it really hits home. If you've ever gotten a syntax error because of some stray character, like a weird apostrophe you typed by accident, it's often the lexical analyzer that found it first. It was just reading along, trying to match one of its patterns, and suddenly it found a character that didn't fit any of its rules. It couldn't even form a valid word. And that's actually a really nice thought to end on, isn't it? The incredible complexity of a modern compiler and all the amazing software it helps us build, it's all resting on this one simple foundational first step. Just patiently grouping one character after another into the basic words that let us speak to our machines.